problem, we're asked to find the domain of three radical functions. So what domain means is list all x values so that when you plug them in, that you would get a valid y value out. So the idea is in this problem, since we're never dividing by a variable, we don't have to concern ourselves with division by zero. That's typically a thing that you look at when you're finding the domain of an equation. You want to worry about when things get divided by zero. Another thing that we want to avoid is getting the square root of a negative number. In fact, whenever you have an even index, in this particular case, the index, because it's not written, believe it or not, it's a 2. And it turns out whenever that index is even, some problems can be created. So if you do not want to deal with what's called complex numbers, you want to keep things real, then it turns out you want to exclude any x values that's going to make this radicand a negative number. This is a bad situation. So square root of a negative number equals bad. It turns out that any even index would be bad. So I can back up and say that if this is any even number, so when we get down to the other part down here, and the index is 4, this is also going to create trouble. So as long as there's an even index here, and this is a negative number, we can think of this as being bad. Suppose I had the square root of negative 4. The meaning of the square root is that you are to give me a number that if I multiplied by itself, I would get a negative 4. And the reason it doesn't work is because when you have an even number of occurrences here, and that happened because this was a 2, there's no way to multiply these two numbers to get a negative, right? If this was a positive times a positive, you'd get a positive out of that, and that would definitely not give me negative 4. And if you were to choose to put a negative number here, you might think that negative 2 times negative 2 works, but it doesn't. Negative 2 times negative 2 is positive 4, not negative 4, so it just doesn't work. So unless you define a whole another number system, this is bad. So we're going to call this bad for the purposes of this video. So here, I want to make sure that my radicand, the 6 minus 2x, one way to approach this is to make sure that it does not come out to be a negative number. You know, we don't want that to be a negative number. So to do that in a more efficient way, we can say is we do want it to come out to be positive. And in mathematics, coming out positive means that you're greater than 0. Actually, it could actually be equal to 0 as well. If 6 minus 2x, if this thing came out to be 0, you'd be left with the square root of 0, and that is mathematically defined to be 0. So that works. You get a valid output for that particular input, so it would be in our domain. So basically, we should also put a line here to say that your radicand, the thing under the radical, can be positive or it can be 0 and things will work out. So if I solve this inequality, I'm writing the things that do work out. So if you just let me solve this inequality, I'm going to subtract 6 on the left and on the right. And 6 minus 6 is 0, so it simplifies out. And then on the right hand, 0 subtract 6 is negative 6. Since the negative 2 is being multiplied, divide by negative 2. Negative 2 divided by negative 2 is 1, and you can write 1x if you want. We typically don't write the 1. Now here's a rule that whenever you divide or multiply by a negative, and this is the only time you do this, but if you're dividing or multiplying by a negative, you have to switch this inequality symbol. So notice I'm going to do that. Instead of it being a greater than or equal to, it has to be a less than or equal to. And then a negative divided by negative is a positive, and 6 divided by 2 is 3. So that rule is true. So since we wrote down the things that make us happy, things that work, this is the domain. Remember what the domain is. It's the x values that if you were to replace the x with those numbers, things would work out and you'd get valid output. So as long as x is less than or equal to 3, then what's going to happen is this thing is going to come out either 0 or bigger than 0, and we can take the square root of positives and we can take the square root of 0 and get meaningful results. So this is the thing that works. So this is my domain. And you could actually even check it, you know, take any of your favorite numbers that are less than or equal to 3, plug it in for x, and you'll see that you can simplify it out and get a real number. Now on this one, it turns out that with odd indices, remember this is called the index right here, and as long as your index is odd, it turns out that this can be anything. It doesn't really matter. Any real number works out fine. It turns out that it makes sense to take the cube root of a positive number, and it also makes sense to take the cube root of a negative number. It works out. So for example, if you want a little side example, I could ask you to take the cube root of, say, 8, and I could also ask you to take the cube root of negative 8. It's because this is an odd index that we have no worries whatsoever. I can tell you already the domain is going to be do whatever you want. You know, it will be happy no matter what, because it doesn't matter if 2x plus 1 comes out to be positive, it doesn't matter if it comes out to be 0, and it doesn't matter if it comes out to be negative, because we can define it. We'll get answers that we like. So the domain is going to be all real numbers on this one. But let me just show you what this means. The cube root of 8 means give me a number that if I multiplied by itself and made 3 copies of it, that you would get the number 8. And I can define that because the answer is 2. 2 times 2 times 2 is positive 8. And then I can also argue that with a negative case, things work out. That the question would be, what do you multiply by itself 3 times to get negative 8? And this time I'm happy, and it's because, unlike the last example, because I have an odd number here, you can take a negative number and multiply it together an odd number of times and it'll work. In fact, if you consider putting negative 2 in the blanks, 2 times 2 times 2 is indeed 8. And then if you look at this, a negative times a negative is a positive. But then you're taking a positive and multiplying by a negative. And a positive times a negative is indeed a negative. So it works. The cube root of negative 8 is negative 2. The cube root of 8 is positive 2. We get answers regardless if our radicand is positive, negative, or 0. In fact, if you want, the cube root of 0 works as well, because if you took 0 and multiplied by itself 3 times, you would get this guy in here, which is 0. So basically, with odd indices, you don't even have to even worry about it. If you are taking the cube root or the 5th root or the 7th root of anything, then the domain is always going to be all real numbers. I wasn't really given any guidance on this, whether we should write our answer in interval notation or inequality or what have you, but typically this is how we would just say it. If you can plug in anything in the world you want, then just say all real numbers. You technically could say x is between infinity and negative infinity if you want, but nothing's cleaner than just saying everything works. So that was a long story for a simple problem. Now the last one, we're back to an even index here. That's what creates problems. So for the 4th root of a negative number, let's say I wanted you to take the 4th root of negative 1. That would mean I want you to multiply the number by itself an even number of times and get a negative result, and it just doesn't work. And maybe the best example is to say, what if I wanted the 4th root of negative 1? There's no answer, because what you put in one blank, you must put in them all. So if you pick a positive number, 4 positives multiplied together does not yield a negative, and 4 negative numbers doesn't work either. So say I know the answer, it's negative 1. But again, 2 negatives multiplied gives a positive, these 2 negatives multiplied give a positive, and a positive times a positive is still a positive. You never get a negative out. So we're back to the first story, that rather than writing what goes wrong, you can write what makes you happy. We say, well, as long as x plus 7 is positive, you can say as long as it's bigger than 0, that would be positive numbers, or 0, so you could say equal to. As long as that thing turns out to be a positive number or 0, I will be happy. So those particular x values would be included in the domain. So when is x plus 7 bigger or equal to 0? You simply solve that equation by subtracting 7. You do not switch the inequality symbol. Remember, that only happens when you multiply or divide by a negative. So here we have x, because plus 7 and minus 7 sum to 0. And then 0 subtract 7 is negative 7. So this tells me I will get valid y values if you plug in numbers bigger than or equal to negative 7. And you should test some of these to see that it works out. Pick a number bigger than or equal to negative 7 and see that it would work out. In fact, let me pick an easy one. Example, let me pick a number like negative 6. You know, on the real number line, negative 6 is bigger than negative 7 because it occurs further to the right. So if I was to take the 4th root and I plugged in x equals negative 6, which is in this range, right? Negative 6 is bigger than or equal to negative 7. Any number on the real number line that satisfies this inequality is going to give me an answer. So if I was to replace x with negative 6, this is what I would get. I would get the 4th root of negative 6 plus 7. Well, negative 6 plus 7 is just the number 1, and the 4th root of 1 makes sense. It's the number that I multiply by itself 4 times to get 1, and the answer would be 1. 1 times 1 times 1 times 1 gives me 1, so the answer is simply 1. It gives me a valid output, and we have no issues. Now, remembering that I promised earlier in the video, why do we switch the inequality when we multiply or divide by a negative? So here would be an example. In fact, we'll just start on the real number line again. suppose that you had a number like -4 and -3, and I just wrote down a true statement that -4 happens to be less than -3, and that's because it occurs further to the left in the real number line. Things on the left are smaller. So what would happen is if you were to multiply or divide by a negative, I don't know which one I want to do. In our case, we divided by a negative. So let me say I divide both sides by a -1. What happens is, over here, a negative divided by a negative is a positive, and you get 4. Over here, a negative divided by a negative is positive, and 3 divided by 1 is 3. So what symbol would you put in here? You know, when you compare the numbers 4 and 3 on the real number line, it's obvious that 4 is bigger than 3, right? It's further to the right. So you'd have to say that 4 is bigger than 3. So look what happened here. Because I divided by a negative, to make this make sense, I have to switch the inequality symbol. It isn't something that mathematicians just arbitrarily define. It's just we have to define it that way for math to make sense.